Hello, calculus students, and welcome to our video review to go over the sample multiple choice questions. Before we begin, let me talk a little bit about how everybody did on these. The average score was 11 out of 20, which I know doesn't sound very good, just a little bit over 50%, but actually that's pretty decent for the multiple choice. These questions are really challenging and not just a calculus topic, but they oftentimes know the mistakes the students make and they put those answers on there. So what I usually tell my students on the multiple choice part is if you can get a little over 50%, you're doing pretty good, and then get the first response along with it to uh, points on that and try to get a passing score. Now, obviously, for your class, you won't be having multiple choice on your exam. It'll be just for free response, but it's still good to go through these problems. And what I mostly want to focus on here is the different skills, just kind of practicing what calculus skills you use to solve these problems. So that way, if you see something like this on your test, you will know what to do with them. Okay, so I've got the screen in front of me showing how everybody did. So some of the problems a lot of students missed, I'll spend more time on. If most of you got it right, I'll kind of go a little quicker. Maybe some of them need a little more explanation. Some go a little bit longer. Okay, and so let me get right started here with the first question. Question number one. Okay, and I'm going to do all my work on this sheet of paper here. So I'll scan that for the end if you want a copy of that. Okay, but I may refer back to the test book that we'll look at a problem at some point. Number one, when you see a limit like this, I mentioned this before. This should look familiar. When you see a limit f of a plus h minus f of a over h, where's it at here? That's on your stuff to know sheet, which I suggest you have with you as you're working. Right? That is the definition of the derivative of f at x equal a. So when you see something like this, we don't know how to solve this algebraically. Actually, technically, you could use L'Hopital's rule, but you can also recognize that that is the derivative of the cosine function at 3 pi over 2. Okay, so um, we want to find the derivative of cosine x at x equals 3 pi over 2. Well, the derivative of cosine x is negative sine x, and then you plug in 3 pi over 2, negative sine 3 pi over 2, sine 3 pi over 2 is negative 1, so that answer is positive 1. So number 1 is A. All right, so with a problem like that, if you ever see a limit in that form, okay, one more time, f of a plus h minus f of a over h as h goes to 0, or limit as x approaches a, f of x minus f of a over x minus a, recognize that those are both the definitions of the derivative. All right, number 2, most everybody got this, so let me just real quick. We want the first derivative and second derivative to both be negative, meaning we want the function to be decreasing and concave down, right? First derivative is increasing, decreasing, second derivative is concavity. So where in the graph is a function both decreasing and concave down, and that is B. All right, number 3, the slope of the tangent to the curve. All right, so when you see slope of a tangent line, that means the derivative. So the way the problem is written, though, we have to use implicit differentiation. Okay, so do the product rule here. So times dv plus v times du. And remember, every time you take a derivative with respect to y, you multiply by dy dx. Plus, same thing here. U times dv plus v times du. And then on the right side, 0. Now, we want to find the derivative at the point 2, 1. So From here, there's two ways you could solve it. You could solve for dy dx and then plug in 2, 1. But if you remember before I said, a lot of times it's easier to plug in the number first. That way when you're doing algebra, there's less variables there. So let's just plug in 2 for x and 1 for y right now. So 1 cubed is 1. And then this will be 2 times 3, which is 6 dy dx. Plus, let's see, that's 1 squared times 2 times 2. So that's going to be 4. Plus 4 times 2 is 8. dy dx equals 0. All right, and now that should be pretty easy to solve. Add the dy dx's on the left side. 1 plus 4 is 5, so subtract 5. So your dy dx is negative 5 over 14, which is C. All right. Number 4. Forgot that was one I told you to skip. All right. Number 5. All right. About half of you got this one right. Give you a function here, wants to know about the points of inflection and the relative extrema. Okay, so points of inflection is when the first derivative changes sign. Sorry, the second derivative, I said it backwards, sorry. Points of inflection is when the second derivative changes sign. The relative extrema is when the first derivative changes sign, local max or local min. So take the first derivative, you're going to have 4x cubed minus 6x squared, and set equals 0. I can factor out a 2x squared. I'm going to have 2x minus 3 equals 0. Okay, so I'm going to have 2 times we're at 0. At 0 and at 2/3. Okay, but now notice, now you can make a sign chart, but you don't even have to do that because look at this. Because that x is squared, what do we know? That's an even multiplicity, right? There's going to be no sign change. There's going to be no sign change at x equals 0. Okay, so the only relative extrema is at x equals 2/3. All right. Now to do this second derivative, take the derivative of the first derivative. That'll be 12x squared minus 12x equals 0. Factor out of 12x. X minus 1 is 0. The zeros are at 0 and at 1. Notice both of these have odd multiplicity, so both of these have sign changes. So these are both points of inflection. So there's 2 points of inflection, but there's only one relative extrema. Sorry, that's supposed to be a 1. 1 extrema. All right, so that is answer C. That is answer C for number 5. All right, so if you just saw the two critical points here and assume they're both relative extrema, that's why you missed it. Okay, so remember, you have to check and make sure that the derivative actually changes sign for it to be an extreme value. Number 6, it gives you a function. F of x is sine squared 3 minus x, which you may want to write as sine 3 minus x quantity squared. And once you find the first derivative, add 0. Okay, so take the first derivative. Now, I noticed that a lot of you put A instead of B. Okay, if that's the case, you forgot the chain rule. You forgot to do the chain rule because you bring down the 2, right? Inside stays the same. Now, times the derivative of the inside. Derivative of sine is cosine, 3 minus x, and then times the derivative of the inside again, right? 3 minus x is my inside function. The derivative of that is negative 1. Okay, and now I will plug in 0, so I'm going to get 2 times the sine of 3 times the cosine of 3 times negative 1, and that ends up being answer B. Okay, so you had to remember the chain rule for that one. All right, moving on to number 7. Solving a differential equation. Hey, we just talked about that on our last unit. Progress check. So to solve a differential equation, we want to separate the variables. So multiply both sides by y, dy equals 4x dx. That's our first step. And then I want to integrate both sides. So that's going to be 1/2 y squared equals 2x squared plus c. All right. And then plug in your initial condition, which I forgot to write down. Y of 2 is -2, so 1/2 -2 squared equals 2 times 2 squared plus c. So that's going to be half of 4 is 2. That's going to be 8 plus c. So my c is -6. Okay, so now I'm going to plug that back in, the function. That's not really a function. Plug it back in the equation right here. And then I need to solve for y. Multiply, oh, sorry, that should be an equal sign. Multiply everything by 2 to get rid of the 1/2. And then the last step is to take the square root of both sides of the equation. Now be careful because it's an x squared. When I do the square root of both sides of the equation, remember there's two answers, plus or minus square root of 4x squared minus 12. Okay, and if you notice in the multiple choice, both the positive and negative are listed. And of course, your test will be free response, so there won't be multiple choice. But you have to know, do you want the positive or negative? And that's where you look back here. When I plug in 2, I want to get -2, not +2. So that's why I want to choose the negative um, answer for that, which is C. So 7 is C. No, number 8 is next, and for that one, average rate of change. Okay, another one almost everybody got. Average rate of change is just slope. So just find the slope. Um, f of 3 minus f of 0 over 3, 66 over 3 is 22. Okay. Average rate of change again is just slope. The algebra definition is slope. Number 9, it gives you a position function. And 2t cubed minus 24t squared plus 90t plus 7. Okay. This one, most of you missed. Only 5 of you got it correct. There's a lot of different answers here. So it wants to know what values of t is the speed increasing. Speed increasing means speeding up. Okay. So can go back to this stuff to know sheet. Um, speeding up and slowing down. Speeding up when velocity and acceleration have the same sign. Slowing down when they have different signs. So speeding up, I want velocity acceleration to have the same sign. So how do I find the velocity? Well, that's the first derivative. So let me do 6t squared minus 48t plus 90. Okay. Set that equal to 0. I can factor out a 6. T squared minus 8t plus 15 is 0. Factor it again. T minus 3, t minus 5 is 0. Okay, so if I'm going to make a sign chart for velocity, and I'm starting at 0 here, it is a parabola that opens up, so it'll go positive, negative, positive. So that's my sign chart for velocity. Now, do the same for acceleration. Go back to find the derivative velocity because acceleration. 12t minus 48, set equals 0. That's 0 and t equals 4. So now I'm going to make a sign chart for acceleration. Again, notice for both of these, I'm starting at 0 because that's what the problem says to do. And this is a line with a y-intercept of -48 and a positive slope, so it goes from negative to positive. Okay, so now we want to combine these onto one chart. And if you remember what I said before is sometimes it might be helpful to make a sort of dual sign chart with velocity on top and acceleration on the bottom and put all the zeros on one sign chart. So velocity is positive here, negative, negative, positive. And acceleration is negative to the left of 4 and positive to the right. So let's see, where's my red pen? When is it speeding up? It's speeding up when velocity and acceleration have the same sign. So 3 to 4 and 5 to infinity, okay, which is your answer E. So that's what you have to do for speeding up or slowing down. You have to compare the signs of velocity and acceleration. All right, next one, number 10. Okay, another one that a lot of people missed. This is one of those that if you did a little bit of algebra at the beginning, you made it easier, okay? So we have an integral of x minus 1 times radical x, okay? Now, remember, we don't know how to do an antiderivative of a product, okay? And there's no substitution because you can't do a u and a du, okay? So what can I do? Well, remember, you can sometimes it's easier to do some algebra first. I can distribute the radical x to both terms, right? I'm just going to rewrite this as radical x times x would be x to the 3 halves, and then radical x times 1 is x to the 1 half. Okay, write it like that. Now you can do the antiderivative pretty easily. Just add 1 to the exponent and multiply by the reciprocal. And same thing, add 1 to the exponent, multiply by the reciprocal. And then, of course, don't forget your plus c. And what answer is that? That is answer D. Okay, so the key again was to distribute this first. So sometimes, remember, you can take um, you can simplify a function algebraically before you either do the derivative or the integral. Makes it easier to do. Um, 11, this limit, let's just look at the problem here. Most of you got this. Um, limit as x goes to infinity. When you see that, that is a horizontal asymptote. When it's a rational function, you want to look at the 3 different cases. The degrees, is it larger on top, larger on the bottom, or equal? In this case, they're equal. You look at the leading coefficients, it's -1/4. So B, -1/4. All right. 12 was an area problem, so let's skip that. 13. Okay. Another difficult one. Only 4 of you got this one right. Uh, gives you this. Which of the following is true? They ask you about the derivative and find y, and what's true of y of 0 is 5 or is y of 1 equal to 5. Okay. So that's a fundamental theorem of calculus problem when you have to take a derivative of a function involving an integral. Okay, so let's talk about that first. Find the derivative, dy dx. Okay, well, derivative of 5 is 0. That goes away. But what happens when you do the derivative of an integral? Uh, remember, that's, again, like I said before, it's a fundamental theorem of calculus. All right, as long as it's from a constant to x, you plug this in for t. But it's not just x, it's 2x. So you have to do the chain rule. You have to do the chain rule. You're going to plug in 2x for the t. So it's e to the negative 2x squared. And be careful, it's a quantity 2x squared. Okay? Uh, not just x squared, it's 2x squared. But now is where you have to do the chain rule. 2x was your inside function. You have to multiply by the derivative 2x, which is the 2. Okay? And then when you square the 2x, you end up with e to the negative 4x squared. So there's your derivative. I'm sorry, 2 e to the negative 4x squared. Okay? So right away, that gets you down to d or e. And then is y of 0 5 or y of 1 5? Well, for this to be 5, we want this integral to be 0. When is an integral 0? When the upper bound and lower bound are the same. What should make these both the same? When x is 1, then you'd have integral from 2 to 2. So I want e to be the answer. So that way that the derivative is this, and when you plug in 1, you get 0. All right, 14. Most of you got this one as well. A slope field, just matching a slope field to the differential equation. It's x over y, so the slope should be 0 when x is 0 and undefined when y is 0. So it's 0 along the y-axis, it's horizontal lines along the y-axis, vertical lines along the x-axis. And which one is that? That is E. That matches up with E. Okay. Um, all right. So that ends the now calculator. Now we're going to move on to the calculator. All right. And 15 and 16, I told you to skip. So let me jump ahead to 17. All right. This one, 2/3, you got it right. Hopefully it wasn't too bad here. If it gives you a graph, if the limit as x approaches b of f of x exists, but f is not continuous at b, where it could be b. So what x value is b? In other words, we want the two-side limit to exist, but the function not to exist. So remember, for a two-side limit to exist, that means the limit coming from the left and the right are equal. So limit coming from the left and the right, okay? Limit coming from the right. Now, a few of you put 2 as the answer, but notice, at 2, it is not continuous, so that's correct. But look at 2. The left-hand limit is 2, but the right-hand limit is 1. So this is not true, okay? So we want the two-side limit to exist, but the function to not be continuous. So in other words, we want a hole in the graph. The graph has a hole. And where is that at? That's at 0, because coming from the left and coming from the right, The two-sided limit exists, but there's a hole there. Okay, so the answer is B, 0. Okay, and I just realized now, maybe some of you meant to put 0, but you saw the y value of 2 there, and so you put 2 as an answer. Okay, so just got to be careful. I'm looking for the x value, not the y value. Right? You don't want to miss a point on a silly mistake like that. So just be careful what it's looking for. Number 18. All right, this one kind of a challenging one here. It gives you a table of values. It tells you the second derivative is always negative. That'll be important in a minute. Select the values of f are shown. Which of the following must be true about the derivative at 1/2? So, or sorry, not 1/2, 1.2. I want to approximate the slope at 1.2. Okay, so here's what we want to do. We want to know that we can approximate a slope. We've done this before. We can always approximate a derivative by using the slope. Okay, so let's take the slope to the left of 1.2 and the slope to the right of 1.2. So if you, let's just do change in y over change in x, the slope between 1.1 and 1.2, and you would get 2 if you do change in y over change in x. Do the same thing to the right. Do the slope between 1.2 and 1.3, change y over change in x. You get 1.7. Okay. Um, So we know that the slope to the left is 2. We know the slope to the right is 1.7. Uh, or sorry, 1.8. Okay, this one is 1.7. If you do between 1.3 and 1.4, is 1.7. This is 1.8. Uh, my apologies. So anyways, the slope to the left is 2. The slope to the right is 1.8. So now what is this important? The second derivative is always negative, meaning the slope of the first derivative is negative. So the first derivative is always decreasing. So we don't necessarily know, if this wasn't true, we don't necessarily know that the derivative has to be between these two, because it could go up and back down, for example, or down and back up. But because this is true, that the derivative is always um, decreasing, that means that the slope at 1.2 has to be somewhere between the 2 and the 1.8. So that's why the answer is going to be D. The answer is going to be D. All right, so the thing to keep in mind whenever you're asked to approximate a derivative and you're given a table of values, just think slope. The derivative tells you the slope, so find the slope near 1.2. All right, number 19. It gives you two different position functions and wants to know how many values do they have the same velocity. Okay, well, we know that the velocity is the derivative, right, of position. So for v sub 1, x sub 1 is sine of t. Derivative sine is cosine of t. Okay, and then x sub 2 is e to the negative 2t minus 1. So do the derivative of that to find velocity of particle 2. Now, for this derivative, you have to use the chain rule, right? So it's going to be e to the negative 2t times negative 2. So negative 2 e to the negative 2t is v sub 2. Now, it simply says, how many times does the particle have the same velocity? Well, that's where your graphing calculator is going to come in handy. You simply graph this function, and see how many times are they equal to each other. How many times do the two graphs intersect? And you get D. They intersect 3 times. These two graphs intersect 3 times, right? So that means that they have the same velocity 3 different times, which is what I was asking. All right, so the key there was just taking the derivative, finding the velocity, and using your calculator to find out how many times those velocities were equal to each other. All right, number 20, it gives us a graph. 20 gives us a graph. Of f, and it defines g of x as the integral from 0 to x of f of t dt. It wants me to find g of negative 1. Okay, so hopefully you all wrote that out as an integral. Okay, so these are kind of things. Make sure you're writing this out. Don't try to do this in your head. Write it out so you know exactly what you're doing here. Um, So g of negative 1 would be the integral from 0 to negative 1 of f of t dt. Okay, now notice this is written backwards, right? Usually the integral goes from the large number to small number. So I want to flip it around and make it negative. It is the opposite of the integral from negative 1 to 0 of f of t dt. And what's the integral from negative 1 to 0? Well, that'd be the area under the curve between negative 1 and 0. So it'd just be the area of this triangle right there, okay, which is 1. But because I flipped the order around and I had to make it negative, that means the answer is B, negative 1. Negative 1. Okay, so which most of you had. A few of you put positive 1, which means I'm guessing you probably just forgot to flip the order around and make it negative. You read that backwards. All right. Um, Next one. Just a few left here. 21. All right. This is kind of an interesting problem. Once you understand what's asking, it's actually not that difficult. It gives you 5 graphs. Okay. Which of the 5 has a non-zero average value over the interval negative pi to pi? Okay. So how do I find the average value of a function? All right, that's one of those formulas you need to know. Again, look, it's on your stuff to know sheet somewhere right here. Average value of a function. It's 1 over b minus a times integral a to b f of x dx. That comes up on your free response as well. Okay, so it wants to know which one on that interval, negative pi to pi, will have an average value that's not 0. Well, the only way for this to equal 0 is if the integral is 0, right? That's the only way for that, because this will never be 0. So this is only way for this to be 0 is if the integral is 0. So what it's really saying is, which of these integrals from negative pi to pi will not be 0? Not be 0. Well, the integral will be 0 if the area on the top and the bottom cancel out. Like these cancel out, these cancel out, right? If I were to draw lines here, these 2 areas cancel with these 2. If I draw lines here, these areas cancel with these areas. But look at E here. If I draw these lines, okay, the area below is larger than the area above the graph. So this integral will be negative, which means the average value will be negative. So E is the answer I'm looking for 21. E. Okay. 22. Differentiable function f has a property such that f of 5 is 3 and f prime of 5 is 4. What's the estimate for 4.8 using the local linear approximation? Anytime you see those words right there, locally linear approximation, or any similar phrase to that, that is a tangent line, right? Line, linear approximation, tangent line. You want to write the equation for a tangent line at 5. Which we've done many, many times before, right? We've talked about that. Tangent line, what do we need? We need 2 things, a slope and a point. Well, guess what? That's what you're given. There's your point, 5, 3, and the derivative of 5 is the slope. So you have all the information right there. You don't have to do any work. All you have to do is write the tangent line. Y minus y1 equals the slope times x minus x1. All right, now it says we want to use that to estimate f of 4.8. So plug in 4.8 for x. And what do we have? I'm going to add the 3 over to the other side. So it's going to be 3 plus 4 times 4.8 minus 5, okay? Which is 3 plus 4 times negative 0.2. So it's going to be 3 minus 0.8, which is going to be 2.2. So there you go. Your answer is A, okay? So we've seen these a lot on free response, all right? So I can guess it's probably going to show up somewhere on your exam. It's something about writing equation of a tangent line and then using that tangent line to approximate the value of a function. That's one use of a derivative is we can approximate values of functions we don't know using tangent lines. All right, 2 more problems here. Okay, 23 gives you a rate of change, a rate of oil being leaking from a tanker in gallons per hour. How much oil leaks out of a tanker from t equals 0 to t equals 10? This was in one of the very last sections we did, 8.1. Anytime you're given a rate of change and you want to find the total amount of change over an interval, you do a definite integral. So the total amount of oil that leaks is simply going to be the integral from 0 to 10 of the rate given, r of t dt, the 2000 e to the negative 0.2 t. So just do this integral in your calculator. That's all you have to do. Just plug that in your calculator and you get the answer. Hold on. You get 8647, which is D. All right, so just do that integral in your calculator. So anytime, again, you're given a rate of change and you ask for a total amount of change, that is a definite integral. All right, last one here, 24. All right, you're given 2 things. You're given a derivative of a function, sine pi e to the x over 2, and you're given an initial condition, f of 0 is 1, and it wants you to find f of 2. All right, Another problem that should look familiar. There was one of our earlier progress checks. We talked about this problem a lot. Okay, this is using the fundamental theorem of calculus. Oh, sorry, dropped my paper here. Uh, Using the fundamental theorem of calculus to rewrite we can take the fundamental theorem and rewrite it like this to solve a function. Anytime you have a derivative and an initial value, you can always find any other y value of the function. Right. So one more time, anytime you have a derivative and then any point on the graph, you can find any other point on the graph. Okay, using the fundamental theorem. All right. So if I want to find f of 2 and I know f of 0. So it's f of 2 is f of 0 plus the integral from 0 to 2 of the derivative f prime x dx. Okay, so f of 0 is 1, so it's going to be 1 plus the integral from 0 to 2 of the derivative function, which you can do in your calculator. So just do this integral in your calculator, but make sure that you add 1. Make sure that you add 1 to it for that initial condition. So let's see here. So this integral is 0.157, but when you add 1, it's 1.157. So your final answer is E. Okay, so that is the solution to those multiple choice problems. So hopefully those explanations helped out. And if you missed something, go back and try and look them over again. And I will, after this, I'm going to post the solutions to the free response questions.